Hello and welcome back to the guided project on the decision tree models. We're using the heart failure dataset from Kaggle. So what we'll first do is we're going to start with an unpruned decision tree to see what we get, and then we'll make decisions from there. So we'll start by assigning the decision tree classifier. We're not going to call any arguments, but let's fit the model as we call it so that kind of kill two birds with one stone. So we'll go X train, Y train. Okay, so run that. And what we're going to do is we're going to get the score of the train and the score of a test. So what we'll do is we'll go unpruned tree that we've assigned to this, just the unpruned decision tree. We'll go dot score and we'll give X train and Y train. So get the score for that. And what we'll do, just to make life easier, we're just going to copy and paste this because it's basically repeating. We're just going to make one small change. So we're going to change this to test. Now we're going to use get the score for the test data set. If we run this, we're going to assign the scores to those two variables. Just to explain this very quickly, if you were a student, you would have access to this. This would already be pre-filled out for you. But what we're doing is we're creating a list of our train scores, creating a list of our test scores. There's only one in there right now, but we'll keep adding to this as we go through our modeling. We're going to model lists, so the names of our models. We're going to put those two, the train and the test scores, into key value pairs in a dictionary. So the key train and then the list is the train scores, test score is the key, and test scores is the list. Put that dictionary into a pandas data frame, and we're going to set the index to the model list so we get the values appearing on the index on the left-hand side, and we'll look at that model. And we can see here, we get a very overfit model. Our training score of 1.0 and our test score of 0.76, really significantly overfitting, and that's very typical of a decision tree in that it will grow through every nook and cranny of your data set and tend to overfit to the noise. So this is the danger of using an unpruned decision tree. So next we're going to define a function to make a confusion matrix so we can take a look at the errors it's making. So what we'll do, I'm not going to go through all of this because if you're a student, you'll have the access to this. And so we're going to just highlight from the metrics in the sklearn that we imported up above. We're going to use the confusion matrix and we'll pass it y actual, y predict. And then what we're going to do to highlight as well, that will create a confusion matrix. We'll put the confusion matrix into a data frame and then we'll plot that with Seaborn's heat map. And other thing that we're going to do is we're going to change the color because we got to have nice pretty graphics. So if we go make confusion matrix, and what we're going to do is we're going to give it the model, so unpruned tree. And what we're going to do is we're going to give it y actual. So let's give it y test. And because the data is set to x test by default, right up here, we'll leave that blank and we're going to try that against the test set. So let's run this. And our labels are also 1 and 0, so we don't need to change those arguments. And we can see here, we're making a lot of errors when we predict no, but it's actually yes. And so for heart disease, saying someone doesn't have heart disease when they actually do could be quite detrimental. And so what we're going to do is we're going to call the tree plot next and take a look at our tree, our unpruned tree. So we'll go tree underscore plot. And then what we want to do is unpruned tree. So we're putting our model as the first argument. We're going to assign feature names to the column names of X. We're going to fill in the colors to make it white. We'll set the font size 9. We want to see the node number and then the class number. And so class name, sorry. And so let's run this. And tree plot is not defined. Let's take a look up where we imported that at the very top of our data set. Let's go jump up to the top. And what we're doing is plot.tree. Oh, and I did tree plot. We got to do plot underscore tree. Brain fart, sorry about that. So let's go down. So let's go plot underscore tree. So we'll run that and take a look at our plot. Ooh, and I forgot to go plot.show. say. Let's actually make that a little bit bigger. We can see it's quite small, very hard to kind of look at. So let's go plot dot figure, and we'll give it fig size, size equals to, I think 12 by 12 should be good. 12 by 12. And so we don't see all these printouts because what's a Jupyter Notebook does, it automatically shows all the details of the object in the last part of the cell. So this is showing all the details of the tree plot, but really what we do is want to see the graphics. So let's go plot.show. Let's run this again. This will take a couple seconds to run. You can see here as it's running, we're not getting all the printouts. So our plot.show is just going to print out the graphic that we want to see. So as this is loading, we can see we get a little bit, maybe even bigger than 12 by 12 would be good, but we can see here, we really kind of went down to the last thing. We can see here that we only have 1 sample, 5 samples, 2 samples, very small amount of samples, really going down to the very kind of every nook and cranny of the data set. Let's go on next to the prepruned tree. So here I have some of the arguments already called. So we'll do prepruned tree equals to, so decision tree classifier. And these are the arguments that we'll put into our decision tree. So we're setting the max depth at 6. So we're going to limit, we're going to pre-prune. We're going to stop the tree growing before it's started, basically. So decision, did I spell decision wrong? Decision tree is not defined. So let's try to start type this again. Decision, that's my fault. The English is difficult sometimes. So decision tree classifier. And what we're going to do, just like we did up above, we'll fit this model right as we're loading it up. So x_train, y_train. And so just to highlight the arguments that we're calling to pre-prune our tree to stop it from growing too much, we're going to set max depth of 6, so it's only going down 6 levels. We're going to set the min sample to 10, so it's not doing these small splits. We're going to set the min samples leaf, so there has to be 10 on each sample or they won't continue to split. Max features, so we're going to use 0.6 every time it builds, or every node, it's only going to use 0.6% of the features or 60% of the features. And so if we run this, let's just take a quick look at the plot. So see here, let's actually copy and paste this from up above, and let's give it the pre-pruned tree this time. So pre-pruned tree. So let's run this now with the pre-pruned tree, and let's take a look and see if we're reducing this very high level of overfitting down to really where we're getting 1 sample. And see here, we still get quite a few levels down. We go basically right down to the maximum depth, but we're not getting, we can see here samples of 15. We're getting a little bit better in terms of overfitting. We're not going to such to really fit down to every single sample, every single observation. So what we want to do here, we're going to take the scores next, just like we did up above. So we'll go pre-pruned tree dot score, and we'll go x train, y train. So because we're going to do this again, so we're just going to copy and paste this, and let's change the x train to x test, and nice and quick. Okay. So you can see here, we'll run this, and we're going to assign those score train, score test for the pre-pruned tree. And so you're seeing same workflow that we had up above, but we're now going to assign, we're going to put in the second item in our list, and we're going to call that pre-pruned tree, and we're going to give it the same dictionary, and we're putting the dictionary into a data frame. And again, passing the index of the model list, so we have our names on the left-hand side, so we'll print those. And we can see we have an unpruned tree. We have 1 and 7.6, but our pre-pruned tree has a train score of 0.87, not quite as good as perfect, but we can see that our test score is much closer to our train score, and this is giving us more confidence that the model will be predictive outside of the testing set. And in production.